Okay, we've talked about momentum and the conservation of momentum, and we've worked a sample problem where we talked about a plastic collision or an inelastic collision where the two masses don't bounce off each other, they stick together and move off as one solid object. Well, there's another type of collision called an elastic collision where two objects or more bump into each other, energy is transferred, momentum is transferred, and they move off separately. And this type of problem here. So let's take a look at working one of those problems. For example, a 200-gram rubber ball rolls across the floor at 12 meters per second. It bumps into a skateboard and stops. The skateboard moves away from the collision at 5 meters per second. What is the mass of the skateboard? Okay, well, to get started, of course, we have to do our drawing. Let's make a drawing of what we're talking about. So there's our ball, and our ball is moving. And our ball has an initial velocity of 12 meters per second. And it stops at the end, so our ball then has a final velocity of 0 meters per second. Okay? And that ball, we're told, has a mass of 200 grams. So mass of the ball, do we have to put final or initial here? Actually, no, because the mass of the ball is not going to change due to a collision. So it's just 200 grams. So now we have a drawing started. We've begun to define some terms. So now we need to take the time out and go ahead and talk about our conventions and our symbolism and stuff like that. So we're all communicating the same way. And as always, okay, we're going to say the up and to the right is positive. And we're going to say, okay, we need to figure out what this v is. Well, v is velocity. So anybody reading our work can then figure that out. M is the mass, okay. All right. Anything else? No. Ball and initial and final, that's spelled out, so it's pretty clear, okay. And now we're going to start talking about the skateboard, okay. And there's our skateboard, okay. And the skateboard initially has a speed of 0 meters per second. So since we went ahead and abbreviated skateboard, let's just be clear and put skateboard over here so we can signify what that SB is, okay? We also have the velocity of the skateboard final, and that's equal to what? Looking back at our problem, that's 5 meters per second. Then the mass of the skateboard is what we're trying to find. There we've clearly identified what we're trying to find, okay? And all the components and all the information that we're given in the problem. So this is a momentum problem, obviously, and so we should go ahead and define momentum. And that's just mass times velocity. And we really don't need anything other than those terms, okay, to work this problem. And so there's all our symbology and conventions in one tight little place that we can follow our work, okay. So our underlying principle then is the conservation of momentum. And that's very, very important. And what that means is that the initial momentum, or the momentum of objects in the system before collision, is equal to the momentum after, or final in this case. Okay? So this is just momentum, mass times velocity. So we look and say, what's our system? It's two objects, the ball and the skateboard, and we can detail out what those momentums are. So it's just the mass of the ball times the velocity of the ball initially plus the mass of the skateboard times the velocity of the skateboard initially. That's it. And then we're going to say afterwards, okay, so if you look, this and this or all of that are the same. And the final terms are the mass of the ball times the velocity of the ball final plus the mass of the skateboard times the velocity of the skateboard final. Okay. Now when we're looking at this, we can realize that some of these terms are in fact zero. So the skateboard's not initially moving. We can say that term is zero because any term multiplied by 0 is 0, and the skateboard comes to rest, and so the final velocity of the ball comes to rest. The final velocity of the ball is 0, so that term goes to 0. And we're just left with those two terms. We're looking for, as I said before, this term there. So all we have to do now is solve this equation for that term. Doing so, the mass of the skateboard is equal to the mass of the ball times the velocity of the ball initially divided by the velocity of the skateboard final. Okay? These are all the terms we have. Okay? All we have to do then is plug in the numbers. Okay? Mass of the skateboard is equal to 200 grams times 12 meters per second, all divided by 5 meters per second. And then we can look at our units and say, well, that meters divided by that meters is 1. So we can kind of strike those out. That seconds divided by that second equals 1. We can cancel that. We're going to end up with terms of our units in terms of grams. That's a mass term. That makes sense. 5 goes into 240 times. 40 times 12 is 480. Mass of the skateboard is 480 grams. And as always, what we want to do is box or highlight or arrow or something to show the reader what our answer is. And there is our answer.